Hello, this is Tom from anti-proton.com. Our rain may have radiation in it. In fact, it probably does have radiation in it. In fact, I've actually detected some radiation in it. There are two real questions. Where does it come from? And how much is there? Well, realistically speaking, some of it probably comes from Fukushima. Some of it probably comes from radon, which washes out in the clouds. It gets picked up by condensation nuclei. If water forms on it, it falls to the ground, that sort of thing. There's two completely different profiles to the way this rain works. And of course there's the old paper towel wipe test that everybody keeps doing on the internet. Well, I keep seeing incredibly high counts, so I thought I might give a little bit of an explanation of how one should properly do this and what one should do if they find a high count in their rain. First off, you start with a Geiger counter, like this guy right here. And I have my other Geiger counter here that I normally use on radiationnetwork.com. But I don't actually have it on right now. The reason I don't have it, well, it's on, but the reason I don't have it connected to radiationnetwork.com is because I have also right here a sample container, which is partially important for what we're looking at. Alright. First and foremost, rain in your water and how to deal with it. And I just got home from work, so I'm a little bit done up, but anyhow. Let me pop this open for this. If you detect fallout from Fukushima, it's not going to change its activity very much given time. 4 or 5 hours later, you should still be getting exactly the same result you got the first time. In fact, months later, you should get the same result. It's not true of every isotope. For example, iodine-131 dissipates rapidly because of its half-life, but cesium-137 and strontium-90, which are two of the major isotopes released, they have very, very long half-lives and will not be changing very much. Needless to say, even if the other materials disappear, you should probably have a relatively consistent reading for a long time. Radon, however, is different. It comes from the uranium decay series, and there's a point at which radon gas decays rapidly, and it goes through a quick series of decays, some of them having half-lives of mere seconds, some minutes, some hours, some days. And the result is you could get readings that rapidly dissipate. In other words, you test them and then within a couple hours they've already diminished some. That's perfectly normal. It's scientifically understood. Universities teach this, they explain how it works. So there's really no debate, I would think, or at least there should not be, about the way that that works. The big debate, however, is how much radiation you're likely to find. Taking a Geiger counter and going to any place on Earth that isn't a uranium mine, that isn't the site of Chernobyl and the surrounding areas, that isn't Fukushima and the immediate areas within, 15 kilometers or so, give or take, going to places other than this should not yield readings in the multi-thousand counts per minute. It should not. If you live in the United States of America, Canada, or Mexico, and you take a Geiger counter outside during, before, or after a rainstorm, and you pick up over 1,000 counts a minute, something is very wrong. You should test your unit. Make sure that it works correctly. And a good idea to test your unit is to have a check source. Now, I've already shown you in several other videos the cheap check source. Just a bag of potassium chloride salt works the best from the grocery store. You buy it, put it in a bag, put your new Geiger counter over it, and test it. See what you get. 6 months later, if you're having a problem, you can put the Geiger counter back over top of it again and see if you get a similar reading. And it'll give you an idea if the Geiger counter is malfunctioning or not, or if it's set correctly, or if you're using it correctly. But if you test everything, your Geiger counter, and worse, if you pull out another Geiger counter and they're both reading similar readings, you're getting over 1,000 counts a minute, you need to start considering the possibility of external factors. Radiation from Fukushima, while theoretically could be that high, almost assuredly would not be. There are these things called fuel fleas that have been discussed many, many times. They're almost like a granule of sand that has a very high activity. It would be a piece of cesium that didn't dissolve into water, or it might be even theoretically even a piece of uranium or plutonium. If one of these little guys zipped through the air and landed right in your Geiger counter, yes, that could generate some serious readings. But if you take your Geiger counter, move it around, take it from one place to the next place, and the readings aren't changing very much, and it's not a matter of the Geiger counter being broken, you truly think that your average ground reading on the ground, on your car, across your area, is reading well over 1,000 counts a minute, 10,000, 20,000 more, you are in the middle of a significant health risk. Now, I honestly, really, truly do not believe that anybody's picking up readings that high. I keep seeing them all over the internet, and that's fine, but I wonder if the units being used are working correctly. I'm not telling anybody that their units are not working correctly. I'm not saying that they're wrong. I'm just saying I am incredibly skeptical of readings that high. If you have readings that high, you should consider contacting your local environmental protection agency. If you're one of those people who believes that everybody's out to get you and the government can't be trusted or whatnot, if you're one of them, then why don't you send your samples to a private university to have it tested, or a private laboratory? Laboratories, you can pay them, they'll test. They'll use a scintillator at a private lab, and they'll tell you exactly what it is that's in your water. Excuse me, because most things that decay, not all, but most, emit a gamma particle. Well, it's actually a wave sort of particle duality, but regardless, they emit a pulse of gamma energy. And that photon can be absorbed by the scintillator, and the energy level will tell the lab what it is that you're saying, and you'll know. And I would find it very, very important, not just for you and your family, but as a service to your neighbors. If you read it over, if you're reading 5, 6, 7,000 counts a minute around your general area, it's nice if you put it up on YouTube to show the rest of us, but I would alert it to the authorities, because apparently you have a major catastrophe going on in your general area. You should never be getting that kind of radiation from your water. Never. Unless you're downwind of Chernobyl, like you're in Belarus, or if you're on a boat in the Pacific 20 miles offshore Fukushima, sure. I'm fine with 1,000 counts a minute rushing all across your way, even 20 or 30. But let me give you an example of what I mean. Let me show you what is required to come up with over 20,000, 30,000 counts a minute, 15,000, anywhere in there. I'll show you. But first, let's take a rainwater sample, and let's see the proper way to do it. The proper way to take your sample, first off, you have an area that's clean that you're going to do your testing on. You'll take your Geiger counter, you remove its safety cover, always hold your finger out, that way your finger is a guide, so you don't touch the container that you're, the area that you're testing. And I'm not really doing this test, I'm just showing you, so if anybody sees any little minor flaws in what I'm doing, I'm not really trying to do it. I'm sure somebody will get something. You test your area. When I do go over it really fast, I'm looking for extreme sources of radiation, things that glare at you. You probably won't get any. So take your Geiger counter and place it in a particular area in the same way that you're going to test. I didn't actually bring something with me to do this, which is kind of odd since I'm making a video. Place something underneath the Geiger counter here to make sure it doesn't touch anything. You might tape it down, and if you have an inspector Geiger counter, well, this is an inspector, but if you have the regular type, you might consider putting a couple pencils underneath it and lifting it up above the area. Let it sit like this and do a timed count for perhaps 1 hour. Divide the amount of divide the reading by the number of minutes, and you'll have your average count per minute. Always use counts per minute because you don't know the energy, and if you don't know the energy of whatever it is you're detecting, then they're microsieverts per hour, millirankins, they mean nothing. They mean absolutely nothing. I mean, they show you large amounts, they can show you that they're higher than they should be, but they don't really have very much indicator other than that. So use counts per minute or counts per second, because you're trying to do this professionally, so you want to make sure you do it like that. Alright? Now, take your paper towel. If you're going to videotape this, let's say you want to put it on YouTube, I would consider using the camera and using time-lapse photography, slowing down and speeding up, and filming the entire thing in one continuous video, like I did for my iPad video. The reason to do that is because it's hard for anybody to claim that anything has been changed, moved, or altered because you have one continuous video. And you just time compress it, which you can do with simple tools like Windows, Microsoft, Movie Maker, I believe, can even do that, or even more sophisticated tools. And you just quickly time compress the timings where the Geiger counter is sitting here testing the paper for a period of time, because nobody wants to spend time watching that. Well, we've tested this area and we know it's pretty clean, and we can test the paper and see if it's clean as well. Now if you were actually testing this, you'd want to spend some time and go over it slowly. We're just rapidly doing this to show you what you would do were this real. You'd fold your paper up. So you're pretty sure the paper's not radioactive. Alright. Now let's go outside because it just rained, and let's scrape some crud off my car and see. I would actually suggest taking a bucket that's clean and catching some rainwater in it. But if you really wish to scrape the crud off your car, keeping in mind that that's going to be a false reading, because the exhaust coming out of people's cars, the hydrocarbons, things like that you're picking up all over the place, some of that stuff has natural radioactivity to it, just a little bit. And as a result of it, it's going to throw your readings off if you're trying to test rainwater. If you're trying to test general exposure in the environment, then that's perfectly fine. So just make sure you know what you're testing to. Let's come back now with some rain in just a minute. Alrighty. So now we're going to perform a swipe test. Take your Geiger counter. Don't touch the sensor to anything. Keep the cap on the sensor so the sensor does not become wet. Now, if you're like me, I have an extreme boot, so I can put my Geiger counter down on the ground without any troubles. I'm going to keep the sensor elevated above the ground. Take the paper towel and prepare to wipe part of the vehicle. As you can see, there's just been a lot of rain, so this is a perfect time to perform a swipe test. Do not try to take a swipe test during the rain because you may damage your instrument. Let's take a test now. As you can see, the front of my car contains dirt. This dirt right here is where we're going to make the test. I have my cloth, and I have approximately 1 square meter of area that I'm going to test. Before swiping the cloth, place your Geiger counter down, unless you don't have a way to do that correctly, which I do. Open the cap. Watch out, because rain particles can still be falling from fresh rain and could fall into the Geiger counter and contaminate it. Never touch the Geiger counter to the surface. Hold it close, but never touch it, or you could contaminate the surface. Make note of the counts per minute that you see on the Geiger counter before you start the test. Now, do a simple surface test to see what kind of readings you pick up. Notice my finger is below, like this, allowing me to guide the Geiger counter without touching the surface. As you can see, you find a little bit, but the question is, do you find a lot? As you can see, we do. Now it is time to recap the Geiger counter. First, we check it for debris. Make sure that there's nothing on it. If you bump the edge of the Geiger counter a little bit, it's not the end of the world. You just don't want to touch the inside here to anything. The inside piece. Cap the Geiger counter. Prepare to perform the test. Alrighty. Move your Geiger counter out of the way. Take your piece of paper and swipe down very carefully. I usually hold and push down. That way I'm pulling and pushing at the same time. Exactly, or as close as you can, 1 square meter. And the reason for this is if you know the exact area, in this case 1 square meter, then you can more readily determine the activity of that area. If you wish, you may go down at a second time, but try not to tear your paper. If you have a lot of water, then you'll want to let the water dry before you continue. As you can see, we have material on the paper. Now the question is it radioactive? We'll see. Alright folks, I'm back. I have the piece of paper, and you'll have to take my word for it because obviously I didn't show you the entire video from beginning to end. Now, if I were actually trying to document something and say, look what I found, I would show you the video from beginning to end. But of course, that's not what I'm doing. I'm trying to show you how to do it, should you ever want to do it yourself. So, anyway, and you notice I did the spot test, and the reason I did the spot test is because if there were very high readings, 200 counts per minute, 300 counts per minute, you'd be able to pick them up. You'd still want to catalog a more accurate sample like this, but doing the simple testing gave you a quick idea, and that's fine. Just remember, you want the statistically longer testing, like an hour testing, if you want to really know when you're posting your information. So here's the piece of paper with the little blackened stuff. By the way, here's a bucket I caught some rainwater in a couple days ago, and I'm letting it slowly dry. Interesting stuff. If you take a bucket of water and you set it out to dry in your house, what I would suggest doing is putting a paper towel over top of it. It prevents like dust from things from getting in it, and if you have a plaster ceiling, you could actually add a little bit of activity to it that way. So a little piece of paper over the top of it, gently. Another thing you can do is you can put just a couple sprinkles of table salt in it, because the table salt will prevent any bacteria most likely from growing in it. If it's enough, a couple of pinches of it in there, it won't really hurt your analysis at all because it's just regular salt. Do not, if you do that, use potassium chloride salt, because that is radioactive and that will very much throw off your readings. Important things to consider. Now, we will take this and do a simple spot test. We remove the cap. If you have a regular inspector model, you'd hold it over top like this without touching it. When holding in a regular inspector model, see, mine has a little container underneath here, a little thing that opens up that would reveal the inside of my model if it were a real inspector. Well, sorry, a regular inspector, because mine is a real inspector. It's just the probe type, the better one. Put your hand down like this, about a half a finger length, and touch it. That way you know you're never touching the instrument. It's important not to touch it. I mean, you will occasionally touch things, and it's hard not to, but it's not a good idea. It's not proper science. Now, here's the Geiger counter. I don't know if you can see it or not, but let's hold this down and see what we get. Without touching it. Just not getting very much. Now, if you recall, when I tested the car, I think I hit up to 60 counts per minute. So, oh, there we go, 54 counts per minute. My average in this house is 33 to around 40, depending on where I am. And of course, I'd run a 1 hour average to know if there actually was any additional radiation. I can already tell you just by looking at this, this is 64 counts per minute. I am picking up radiation in this. As I expected, I have soot here. You're going to find more soot than anything, a little bit more radiation in soot than normal. Now, I would run this for an hour, and then as a baseline, then run it again with this over it, taped down perhaps like this so it's near without touching it. Lift it up with something underneath it on both sides to prevent it from touching it. If it were a high enough level, I would use my glove. Let me show you something interesting though, before we finish up. Let me show you what's required, how much radioactivity is required. Let me explain what 5,000, 10,000 counts per minute is, because it's high. That's a lot of radiation. It's not going to kill you or anything probably, but it's not a good thing. Radiation is deadly when it gets inside of you, breathing it, ingesting it, getting into cuts and things like that. And it's dangerous when you're exposed to it as well, because it will go through your body and your skin depending on what type of radiation it is. But it's more so dangerous the other way. I do not keep this here normally because I have my Geiger counter on radiationnetwork.com, and I don't want to. This is an alpha source, so realistically it probably would never affect it. But it's an important thing not to take any chances. This is a sealed source. Well, that's not quite true. The bottom part is actually exposed, but generally it's pretty much a sealed source. So there's very little to worry about. This is a polonium-210 check source. This check source, and let me flip it up so you can see, this check source contains 1/10 of 1 microcurie of polonium-210. Very, very, very nasty stuff. This is a Class 7 nuclear material, but it's NRC exempt. And the reason it's NRC exempt is because of the fact that, well, I have very, very small amounts of it. Let me put it down on the table. Now, here it is on my table. Let me give you an example. This is the cloth, which I'm not touching. Notice I'm getting 28 counts per minute, 30. Here is a tenth of a microcurie of polonium-210. Let me get this a little closer without touching it. It's hard to get close to this without touching it. We're at about, let's see, 5,000 counts, 6,000 counts, a little closer, 12, 16, 17. We're at almost 20,000 counts a minute here. A little bit closer without touching it, getting awfully close. 19, there. That was 20,000 counts per minute. I had to come within 1 centimeter of 1/10 of a microcurie of polonium-210 in order to get a reading that high. This stuff is incredibly dangerous. It won't hurt me as a human because it's alpha particles. It has a very, very short distance. If this were a beta or a gamma source, I could pick it up well up here. But regardless of that fact, you get the idea? And what I'm trying to point out by this is that it takes a significant amount of radiation to cause 20,000 counts per minute. This is decaying in reality at approximately 3,700 decays per second. So that's 3,700 becquerels. And that means that this little guy here is spitting out 222,000 decays a minute. And yet I'm only able to detect about 26,000 from it. That should tell you how inefficient a regular Geiger counter is at picking up these types of radiation. That being the case, I know this is alpha radiation, it's different than gamma and beta, but they're sort of similar in a little bit of ways. That being the case, if I were picking up, let's say, 10,000 counts from this paper towel, and my efficiency is not 100%, then that means this paper towel would be putting off tremendously higher than that in reality. One would have to ask, how on earth would this kind of radiation get all the way over here? Now, I have found radiation in my water. I have. If you look at my videos, you'll see it. Many people I know and trust have found radiation in the air, raining down upon them. It's small amounts. If they detect, let's say they have 50 counts per minute normal on their Geiger counter, they're detecting 70, 80, 90. I've even seen as high as 200, but the higher ones usually seem to be a result of radon washout, otherwise known as radon daughters. Not always the case, but less likely are they Fukushima radiation. And pretty much this has a lot to do with the fact that the air disperses as it moves. And yes, I understand the principles of the jet stream, but regardless. So the point of the video is not that there isn't radiation, and it's not that radiation readings that are shown on the internet are somehow wrong or whatnot. It's that if you do find those kinds of readings, you need to report them to somebody. Not just put them on YouTube. It's important to put them on YouTube and let everyone know, but also let other people know, like the authorities, people who need to know. Because it's a service to your community if that's the case. And if you're not going to report them to anybody and you're just going to put them on YouTube, I wouldn't worry about it at all. Because it doesn't help anybody. Regardless, if you ever get radiation levels like this, that's unhealthy. Well, this is Tom. from anti-proton.com. Bye-bye.